This video I provided to give an example of what we've been talking about in the previous distributions lecture. Our big question, or the big issue of the day, is that you need to think of the concept of the probability of belonging to a diseased or a normal distribution. You've got a person in your chair, you're trying to figure out if they're okay or if they have an issue. And you do a bunch of tests, and the results of the tests are going to help you decide if this person has some sort of issue that needs to be addressed. I'm hoping that you are listening to this lecture after listening to the previous one on distributions, and you've done the 5-question homework problem. There will be a homework problem after this video as well that helps you understand the concepts presented here. So before, we had this silly little example of being male or female based on height. Not exactly the best determiner of gender, but it illustrates what we do. A more, probably a little bit better example, and one that is kind of along the same vein, is the prevalence of glaucoma. Does your patient in the chair have glaucoma? And you're going to give some tests, and you're going to say, is this person likely to have glaucoma or less likely to have glaucoma? Only about 2% of people over 50 have glaucoma. So you're looking at the person in your chair is not likely to have glaucoma if you're just looking at it cold with no other information. So there is a classic study done around 1992. It's actually still going on. The original Beaver Dam population is still being studied as they get into their later years. But about 5,000 people were of this little town of Beaver Dam in Wisconsin, about the whole town, were examined for the presence of glaucoma. They've since also looked at AMD and other diseases as well. But here we're looking at this. Now, the thing that's nice about this study is they published the distribution. And if you look, down here's the x-axis. This is IOP. And the y-axis is the percentage of people in each of these categories. Now, at first blush, this looks like an asymmetric skewed distribution, but if you look at the interval here, it's 0 to 12. And if you broke these people out, now not too many people have a 0 IOP, but the number goes down to 6 or 7. And it would have looked a little bit more symmetrical. Whether you would have concluded that it was symmetrical or not, that kind of remains to be seen. But in any event, this is what they found. Now, if we come out here to the 22, 24, 25 plus, we notice that's 3.9, that's about 0.8, if I'm seeing that right, is 4.7, or about 5% of the people are at this level, or 22 or greater. If you know your IOP criteria, it's generally considered people are hypertensive if they're greater than 22. That came from this study as well as many others that have since examined this. This happens, probably was one of the first. So I wanted to simulate the population so I could construct some graphs of the frequency distribution of normals and the frequency distribution of those with glaucoma. And this slide, which is available in your handouts, kind of talks about some of the things. This was a cross-sectional study, so they just went out, hit the population, found a lot of people with glaucoma. And of course, when they found the people that had glaucoma and they knew they had glaucoma, they were very likely taking eye drops to reduce their IOP. So when they measure their IOP, they don't have their IOP for when they're not on the eye drops. So I looked at there was a big study that looked at people, the ocular hypertension treatment study looked at the effectiveness of eye drops, and that was used here. So I adjusted, because their IOP were underestimated, I adjusted for my simulation purposes just a guess at what IOP would be if they weren't medicated. Now, the red curve here is those people who are not glaucoma, and the green curve is the people that are. And only 2% of the population, the entire population, has glaucoma. And this space right here, this black line is the 22 cutoff. And this little area right here, I magnified up here. So you can see that at 22, 23, and so forth, if you have a patient in your chair that gets a 23, they actually have a higher probability, a higher frequency. There's going to be more of them that are not going to have glaucoma than do have glaucoma. So even though it's a very small proportion of those people that don't have glaucoma, it's still more than the people that do. Now this graph's a little hard to do much with because it's just so overwhelmingly non-glaucomatous. So what I did was I took the log of the y-axis. The log squishes down the big numbers and increases the small, so it distorts this graph, but it doesn't really change the proportions, it doesn't really change the proportion. I suppose if you measured the proportions on a log scale, they'd be different, but this is what you see. So this crossover point right here is around 25. So at 25 something, 25.9 actually, you're as likely to have glaucoma as not. But all the people to the right of this curve have had IOPs greater than 22. Now, only the people under the green curve that are over here, the A's, those are people with glaucoma that were correctly diagnosed with your little IOP test. The B's are people that scored higher than 22, but they're under the normal curve. All these people, you would say, you might give an initial assessment, well, they could be glaucomatous, but really they're normal. If we look over here, we have A as true positive, so these are positive on the test, greater than 22, and it's true because they fall under here and they're in the glaucoma group. B is the false positives. They also were greater than 22, but in fact, the people under in this range do not have glaucoma. C is the false negatives. These are people under this green curve, and they're less than 22. And so you would say they're, you would kind of think, well, they don't have glaucoma because they're under 22, but you would be wrong in this proportion of cases. And the D's are the true negatives. Those are the normal people that are less than 22. So the total percentage is everybody, the sum of both the red and the green curves. All right. We can put this into a little table, our A's, B's, C's, and D's. So the A's, that's those people, or first let's look at those people with glaucoma. That's everybody under this curve. And those people with no glaucoma, that's everybody under the red curve. And then if they have an IOP greater than 22, and they're in the glaucoma curve, that's these A's, that's our true positives. And then B's are the false positives because they scored above 22. And you look at this table, same way with C is people that were less than 22, but they had glaucoma. And no glaucoma are the Ds. See, most of the people are Ds. Most of the people, and you can see from this graph, most of the people don't have glaucoma. So that's 97.9% of the people don't have glaucoma. And when you look at the people less than 22, you add in these guys, you get 99.1% of the population is less than 22. And so that's a lot. Now, you will see in the literature sensitivity and specificity, and sometimes you'll see positive predictive and negative predictive values. So sensitivity is a good number for understanding the quality of the test, but it's a bad number for you as a clinician because this is the proportion of people that were actually had glaucoma and passed your test. But you take 0.007 and divide by the sum of these two and you get 0.37. So the sensitivity is less than 50%. In other words, if you flipped a coin, you would do better at guessing than finding the sensitivity this way. It's 37%. So if somebody comes up positive and they're greater than 22, you're going to be right 37% of the time saying they have glaucoma. It's really not very sensitive. But the point is, with this test, you know that the person has glaucoma, and then you're just seeing how sensitive it is. With specificity, you know the person doesn't, and then you look at the proportion here. Now, this is 97.9 plus 0.025. So specificity, the ability to say somebody doesn't have glaucoma when they don't, it's highly specific. But if you think about it, if you have a patient in your chair and you're trying to assign the distribution, you don't know which one of these they are. So sensitivity and specificity are not the values that you care about. You care about, given they have an IOP greater than 22, do they have glaucoma? And so that's 0.007 divided by 0.0095, which is 0.74. So your positive predictive value is 74%. Now that's not great, but it's definitely better than if you were just thinking in terms of sensitivity. So the probability that you're correct if somebody exceeds 22 is about 74%. Down here, this is given that they don't have, they're less than 22, you have a 99% negative predictive value because it's 97.9 divided by 991, that's 99. So that's basically these things you're going to hear about sensitivity and specificity and positive and negative predictive value. There are other things that make, even though this is the one you're most concerned about, positive and negative predictive value, you also have to consider prevalence when you're looking at this and trying to calculate what the true positive predictive value and negative predictive value. In this example, it was a crossover or a study that was just a survey of the people, and so it's pretty accurate, but a lot of times they use case control studies, and this number, it doesn't work as well, and you have to consider prevalence. And you'll get to that later in your course. We're not going to cover those things today. I'm just mentioning that. So I think that you can see if we just did glaucoma IOP screening, we wouldn't do very well in terms of picking out people with glaucoma because the overlap is just so great. Well, it turns out other measures that have been shown to be significant in the past, age, central corneal thickness, vertical cup to disc ratios, Humphrey visual field pattern standard deviation tests. These also, if you look at these and take plus or minus standard deviations around these means, it's a mean standard deviation, you'll see these overlap, all of them overlap a lot. There are not really good individual measures. Now, if you're outside normal on everybody, you can be pretty sure that your patient has a pretty good probability of having glaucoma. But if they are not overlapping in all these, if everybody is less than the criteria, a person very well may have glaucoma, but you're not going to guess that very well. You're going to be wrong. So it's a tough task to figure out if which distribution the person belongs to, if the distributions don't overlap very much. Now, a lot of your stuff is going to be with, is the person myopic or not? And it turns out, as we saw, the leptokurtic distribution of emmetropes is so tight that you don't have to be a very big myope before you're pretty sure the person is not emmetropic. So there's not very much overlap there once you get past a negative 0.5 diopters. So it's easy in the case of myopia and hyperopia, but it's not so easy in terms of other things like IOP and glaucoma. So diagnostic tools, the function of them is to assign people to different distributions. Again, because a person is normal does not really prove to you that they don't have the disease. If the person is not rejected by the normal criteria, and you're not excluding that, it doesn't really mean that they don't have the disease in many of these tests that have so much overlap. And as you're going through and making your decisions, I'm really hoping you remember this and keep this in mind. It's a critical point. Okay, that's it. Do your homework.